Okay, welcome to Algebra Essentials. We'll be looking at index notation. Index notation is used to write expressions such as this big long 3 by 3 by 3. I'm just going to write down the number here, 3 by 3 by 3, and instead of writing that big long onerous expression, we can write it in shorthand notation as shown here called index notation. So we've got 3 to the power of 6. Okay, the smaller number here is known as the index. So this is the smaller number here, the top right hand one. It's now the index or the power. Okay, the next step here in index notation, we're going to have a look at a worked example here. Example 1, we're going to try and find the value of 6 to the power of 3. I'm just going to draw underneath here, 2 to the power of 5 and 8 to the power of 4. The answer for that is 6 to the power of 3 means 6 multiplied by 6 multiplied by 6 3 times. When you multiply that out, you get 216. 2 to the power of 5 is the next one. Doing the same sort of process. 2 to the power of 5 means 2, one of them. There's the second one. Third, fourth, and fifth. So that means 2 to the power of 5 gives you the answer of 64. And 8 to the power of 4, here we go. 8 times 8 times 8 times 8. So that means you multiply 8 by itself 4 times. Answer 4096. Continuing on with index notation, example 2, find the missing number. So here we've got 6 to the power of 3 multiplied by 6 to the power of 6. We want to find this question mark, the missing number. And next example is 2 to the power of 4 times by 2 to the power of 3. We want to find this missing number again. I wonder if you can do that. Can you see the pattern or the rule that goes with this index law? And the third example here, we've got 8 to the power of 5 divided by 8 to the power of 2. What is the power number when we put those together? 8 to the power of question mark. And the answers here are as follows. If we have a look, 6 to the power of 3, 6 to the power of 6. We can see if we expand that out, we get the 1, 2, 3 sixes that we have here, and then we get the 1, 2, 3, 4, 5 sixes that we have here. If we add them all up, we can see the answer is 6 to the power of 9. Next one here, again, we expand it out in the powers of, or power numbers of 2 here. Second, third, and fourth number, and then for the second one, 2 to the power of 3 is 3 of them. When you add it all together, there's 1, 2, 3, 4, 5, 6, 7. Hence the answer 2 to the power of 7 in index notation form. And the next ones, if we have a look here, we can do 8 to the 5. We expand it 1, 2, 3, 4, 5. In the bottom, we've got 8 to the 2, 1, 2. So if we cancel 2 8s at the top and the bottom, we're left with 8 times 8 times 8, which is 8 to the power of 3. Okay, looking at the next slide, we've got index notation. When the bases are the same, the index law applies when multiplying. That is the rule below. A to the power of n times by a to the power of m equals an plus m. So you literally add the powers together when they are bases are a or x. When they're multiplied, you add the powers together. Addition. Next law in index notation is when we divide the bases the same, we get the following form. So we've got a, the base to the power of n, divided by a to the power of m. What we do now is when they divide, you can see that we subtract. So that's the rule for when we're dividing. When the bases are the same, we subtract the powers from the top to the bottom, numerator to denominator. Well done. Okay, here's some more rules. We're going to find another rule that comes out of these other two rules. So if we use the above rules, we can find another rule. So if we go 8 to the power of 3 divided by 8 to the power of 3, according to the rule, that works out A3 take away 3 is 0. Now if we use the way that we expand it, A times A times A over A times A times A, we get 1. So that shows us another little rule that anything to the power of 0 equals 1. So we have to commit that in mind. So 500 to the power of 0 equals 1. 10 million to the power of 0 equals 1. That's the rule. We have to abide by that. So we're going to have a look at a worked example, see if you can work it out. I'll just pause it a little bit. So example 3 here says 6 to the power of 3 all to the power of 4 and 2 to the power of 4 all to the power of 3. So pause the video and have a go at the answer. After you pause, hopefully you got an answer for this. For number A, we've got 6 to the power of 3 here. 6 to the power of 3, we've done it once, twice, 3, 4 times. That's because of the 4 power here. When we take away the brackets, we see there's 6 times 6, 12 times, and that's hence the number power here. I hope you've done the next one correctly. If not, here's the answer to go through it. To the power of 4 altogether in 2, so there's one lot. To the power of 4, there's a second lot. And remember, there's 1, 2, 3, 4 of them. So when we take out the brackets, we can see as we count 1, 2, 3, 4, 5, 6, 7, 8 here. So when we use the rule a to the n in brackets to the m, it means a to the n multiplied by m. So everything inside gets multiplied by the power on the outside. Here's confirmation of the new rule. Here, the new rule here is a power of base to the m. Outside the power n is what happens is we multiply the number m by n when we have this set up, and that's a new rule we much abide by. Now we're going to start a quick 5. Pause at the end of these questions, have a go as we go along, and then the answers will come shortly. So the first question is, write an index form 7 by 7 by 7 by 7. So write in that index form, please. Question 2, find the value of 2 to the power of 3 and 5 to the power of 0. Question 3, fill in the missing numbers. So we've got here 3 to the power of 3 times by 3 to the power of 6. Tell me what question mark 3 to the power equals to. And then 3 part 2, 6 to the power of question mark divided by 6 to the power of 2 equals 6 to the power of 5. Can you give me an answer to those questions? So pause the video at the end of this, give yourself a minute on each one, and then go to the next questions. Here comes question 4 and 5. Fill in the missing powers. 625 equals 5 to the power of question mark. For part 2, 1 equals 4 to the power of question mark. And the last question, simplify in index notation form. Number 1, 3 to the power of 2, close brackets, to the power of 4. And then here we've got open brackets, 7 to the power of 3, close brackets to the power of 5. What is it in terms of 7 to the power of question mark? Now again, pause, have a go at the questions, and here come the answers. Here are the answers to quick 5. If you've got 7 to the power of 4, well done, good job. Number 2, find the value, that's a number value. 2 part 1 is 8, and 5 to the power of 0 is 1. Remember that rule, a to the 0 equals 1. That's a rule you must remember and commit to your memory banks. Number 3, fill in the missing numbers. Remember to use the rule a to the n times by a to the m equals a to the n plus m, where you just add the index powers. So we've got 3 to the power of 9 at the answer there. And this one here, we find that it's division. Remember that a to the n divided by a to the m equals a to the n minus m. So here, the number here, 7 take away 2 gives you 6 to the power of 5. So there's your answer for that. Here's the final answers on the quick 5. Question 4, part 1. Question mark equals 4, equals 625 equals 5 to the power of 4. We multiply that out, 5 times 5 times 5. This one here, remember the rule again pops up. A to the 0 equals 1. In this case, 1 equals 4 to the 0. This will be reading that. And the last question, here we go, using that rule, a to the n multiplied by m equals a. We multiply the powers. So 2 times 4 is 8, hence the answer. And here we find out in index form it's got to be the base 7, and then 3 times 5 is 15. I hope you did well in those. If not, practice makes perfect, and if you want any further information, please don't hesitate to ask. There'll be more materials available shortly.